Yeah, hi. We are from SVS Embedded. The project title name is called Arduino based data acquisition system using Labview. So in this project we are using an Arduino Uno R3 SMD board, and we are using 4 sensors. Those are LM35 temperature sensor, one MQ2 gas sensor by smoke sensor, and one LDR sensor. So here we are using a third sensor is LDR sensor, the light dependent sensor. When the light is falling onto the sensor, the output voltage will be vary. So it is connected to the A0, A1, A2. These three are the analog sensors we are given to the Arduino board. And the fourth one is the fire sensor. It is photodiode, IR photodiode. When the light falling onto the light, that output voltage will be vary. It is connected to the digital pin of port number 2. And we are seeing the data onto the Labview monitor, temperature, thermometer, smoke indicator, and L garage. So it is connected to the USB driver. It's connected with RxD0 and TxD1, and the outputs are temperature. It is giving the output to the DC motor. When the temperature crosses 60 degree and above, the motor should be on here. So here smoke sensor, we are using the alarm. At the same time, smoke and fire, these two, if anything should be happen, like smoke occurred around 700 and above ppm, so it will give you the alarm. So if the light is light, here we are using LDR, it should be an LED output. So here the concept is, when the sunlight is high, the light should be dark, means light intensity should be less. If light intense, LDR means if the light room of the light, if the light will be decreases, the LED of the light should be increases. So this is the block diagram, and these are the port pin numbers. Let us coming into the hardware part. So here we are using you can go for the direct computer power supply, otherwise you can go for separate power supply also. 230 input step down transformer, 12 volts output AC is here, bridge rectifier, filter capacitor, 7805 regulator, and one LED. So this entire section is called 5 volts power supply purpose we designed for power supply section. So that power supply is given to the microcontroller board of 5 volt and ground. That 5 volts and ground is distributed to all the units. And here I am using an Arduino Uno R3 board and the R3 board. So here the ADC, and these are the port pins. So here 7, 8, 9, 10, 11, 12, and these are the data lines of the LCD. Here 16x2 LCD display, character LCD display. Whatever the process is going on the controller, that should be displayed on the LCD, like it's a monitoring unit. So exact output should be displayed on the LCD. And we have a 4 sensors now. Those are temperature, it is given to the A0. LM35 precious temperature sensor, minus 55 degrees centigrade to 150 degree, and we given a set point called 60 degrees. If the 60 and below, fan should be off. If 60 and above, fan should be on. And here we are using a smoke sensor by gas sensor, that is connected to the A1 of the Arduino board, analog channel 1. Okay, so here we given a 700 ppm. If 700 and below, alarm should be off. 700 and above, the alarm should be on. And here we are using an LDR, light dependent resistor, and that should be given to the A2 of the Arduino board. When the sunlight is falling, means the light should be output, means if the sunlight is heavy, the light should be dim. And here we are using one fire sensor, IR photodiode. When heavy high intensity light will be fallen, that output will be low, and that will be given to the microcontroller of the second pin. And the outputs are third, fourth, and third, fourth, fifth. Third is the light PWM LED. Here you can use third, fourth, fifth, sixth, 9, 10, 11. These are the PWM pins. You can use any of the PWM pin. Like I use in 3 is the PWM pin. Okay, let us going into the output. Open the Labview. Okay, now I am giving the power supply. Okay, 1 minute. It is not connecting. Okay, so it is connected. Open COM port 4, run. Okay, na? And we are seeing the data onto the Labview. Okay, temperature, thermometer, smoke, indicator, light, garage, and these are the block diagram, and these are the output units, and we can see the data onto the read buffer register. Read buffer window, and whatever we are getting the data and we are seeing on the LCD, at the same time we can see the output onto the read buffer register, means read buffer display. If you stop, you can click stop, otherwise we can see the outputs. And I am using one iron rod. If temperature 74, and we can see the data 74, and the fan should be on. Okay, okay, fire, fire, smoke, smoke, 1,000. Okay, light, torch light. Okay, light intensity. Okay, if I am close, light intensity will be high. Okay, you can see light intensity is decreasing. Okay, so we have a total. Okay, smoke 700. So ఇది అది కూల్ అయిపోయింది, ఎక్దమ్ కూల్ అయిపోయింది. if 700 and below, the smoke will be stops. Okay, L for light, S for smoke, there is no fire, but alarm should be. So we given heavy butane gas is given to the inductor coil, like that it will be cooled. So we can insert another 3 sensors also in this project, and we can display it on the output of the Labview. I'm thanking you. If there is any doubt, let me know to SVS Embedded, and we can ship the projects to the national and international students.